Alright, so this video is first off about inverses and identities, these related ideas, and then we'll use that to solve systems. So an inverse and an identity. These are two linked, so it's hard to talk about one without the other. So let's look at this in some examples that you already know about, addition or multiplication. So inverses are the things that would undo each other. As in, if I subtract 2, then add 2, I've really done nothing, right? And then when you compose two inverses, when you do two inverses together, you get the identity. Now the identity is, for addition, 0. So the identity is the thing that does nothing, if you want to think of it that way. So you can think of it two ways. You can think of it as the thing that does nothing. So for addition, that would be 0, like anything plus 0 just equals that thing. And for addition or multiplication, it'd be 1, because 1 times anything is just that thing. So you can think of it as the number that does nothing for the operation, or you could think of it as the result of doing inverses. So for multiplication, we could use anything like, I don't know, negative 1/3. Negative 1/3 times negative 3 over 1 would equal negative times negative positive 1. So these two little guys are the inverses. Those are inverses for addition, and these are inverses for multiplication. The result of which, under the given operation of multiplication or addition, gives you the identity. So 0 for addition and 1 for multiplication. So you've seen that before. But what in the world does an identity look like for matrices? Well, we want it to be the thing that does nothing when we multiply by it. So for matrix multiplication, we'd multiply rows by columns. So we're going to have 1 times that first question mark plus 2 times that second question mark, right? And we want that to equal, well, we want this to be an identity. Stop it. So we want it to do nothing, so we want to just get 1 back. So the only way we can do that is if this were a 1 and that were a 0. So that makes this a 1 and this a 0. Alright, now let's see. If I multiply this, or, whoops, not that one. If I multiply this by that, well, it gives me 3 times 1 plus 4 times 0, which is going to give me 1 and 3, which are the two entries that I should be getting. Okay, let me make a little room there. And then if we do the second column, that times that, well, that's going to be 1 times that first question mark, and then 2 times that second question mark. So I want that to end up with getting me a 2. So that means I want this to be 0, and I want this to be a 1. That way that gives me 0 plus 2 times 1 is 2, gives me the 2 there. Alright, so if that is true, let's say that these are now 0 and 1. Let's multiply these. What do I get? This times this. So that's going to give me that entry, because it's the bottom row, second column. 3 times 0 is 0, 4 times 1 is 4, gives me 4. So that gives me my answer back. And you can see that indeed if I did 1, 0, 0, 1 here, it's going to multiply back and give me 1, 2, 3, 4. So an identity matrix, if you didn't understand it all that, it's forgivable. But the identity matrix is ones all along the diagonal, and it has to be a square matrix. So for a 2 by 2, that's the identity. For a 3 by 3, it's ones along the diagonal and the rest zeros. And that would be the identity for a 3 by 3 matrix. For a 4 by 4, same pattern. Alright, those are identity matrices. There's a different identity matrix for each sized matrix. And it always has to be a square matrix. So if I have to verify that these are inverses, well, that means that A times A inverse should give me an identity, and in this case a 2 by 2 identity. So my answer should come out to be 1, 0, 0, 1. That's how I prove that these are inverses. So let's do that. That's going to give me 1 times negative 2 is negative 2. 2 times 3 halves is plus 3. And then top row, second column, 1 times 1 is 1. 2 times negative 1 half is negative 1. We're going to do bottom row, first column. It's a negative 6. And then a 4 times 3 halves is 12 over 2, or 6. And then bottom row, second column, is going to be 3. And then half of 4 is 2. So 4 times negative a half is negative 2. Simplify all those out. That gives us a 1, a 0, a 0, a 1. So those are inverses. We said that only square matrices have inverses. So that means this and this are inverses of each other.